All right, let's look at this problem. So this is number 10 on your homework, section 3.2. So the question is a measure of 28 inches far from a mean of 18 inches? As someone with knowledge of statistics, your answer, it depends, and request the standard deviation for the underlying data. Suppose the data come from a sample whose standard deviation is 2 inches. How many standard deviation is 28 inches from 18 inches? So to figure that out, you basically find the z-score. So you take your data point x minus the mean divided by the standard deviation. So we have a score of 28, which we're comparing to the mean of 18, and you divide by a standard deviation of 2. All right, so we get 10 over 2, which is equal to 5. Okay, so that answers part A. So part B says, is 28 inches far away from a mean of 18 inches? Well, in statistics, a data point is far away from the center, from the mean, if it's more than 2 standard deviations away from the mean or less than 2 standard deviation away from the mean. So in part B, this is the correct answer. So yes, because 28 inches is more than 2 standard deviations away from 18 inches. So yeah, if you have the data values and you have 18 here, 28 is far away in terms of how many standard deviations. So if you measure things in terms of standard deviations, we have 2, 4, so this is like 20, 22, 24, 26, 28. So each of these is 1 standard deviation. Right? So anything within like 2 standard deviations away from the mean is not far away, but anything past 2 standard deviations away, higher than the mean, that it is far away. So 28 is very far away. Okay? Same goes on the other side, like if you're lower. So if you have anything lower than, if I subtract 2, 16 and 14, anything lower than 14 would be far away from the mean of 18 also. Alright, suppose the standard deviation is 8 inches. In that case, it's 28 inches far away from a mean. So let's find the z-score here. So we have 28 minus 18, but this time divided by 8. 10 divided by 8 is 1 point something. Alright, so let's actually do that. 10 divided by 8. And get 0.125. That's not right. 10 divided by 8 is 1.25. I missed the button. Okay, so because this is smaller than 2, alright, so kind of looking at the graph here, about 1.25, we're about here. Different graph, right, because we have different standard deviations. Okay, so we have 18, we have 28, so this is like the center, but now the standard deviations are, each standard deviation is 8 units, so like 18 plus 8 is 26, that's 1 standard deviation. And the next 26 plus 8 is going to be 34, that's 2 standard deviations. So because 28 is smaller than 2 standard deviations away from the center, then the 28 is not far away from the mean. Okay, so in this part B, with the 2 standard deviation, the data is all squished together. All right, so something like 28 is very unusual compared to the rest of the data. But for part C, the data is more spread out. That's why he has a bigger standard deviation. That's how you know it's spread out. So a value of 28 is not much bigger than sort of the rest of the data. Okay, so that's what you use the z-score for. All right, let's look at this problem right now. Scores of an IQ test have a bell-shaped distribution. Okay, so bell-shaped distribution with a mean of 100 and a standard deviation of 15. So this is the mean is 100 and the standard deviation is 15. Use the empirical rule to determine the following. What percentage of people has an IQ between 70 and 130? Alright, so the empirical rule gives you percentages within standard deviations. So if I'm one standard deviation above and below, alright, so because the standard deviation is 15, we do 100 plus 15 is 115. 100 minus 15 is 85. So the empirical rule says that 66% of all the scores are between those two values. Okay, so the empirical rule is like 66, 95, 99.7%. All right, so that's kind of, those are the relevant numbers. Okay, so 66 means 66% of your data is between one standard deviation below and one standard deviation above the mean. Alright? The 99 is 2 standard deviations. So if I go 2 standard deviation above the mean, 100 plus 15 is 130. And below, subtract another 15, we get 70. Then the empirical rule says that 95% of people of the data is between 70 and 130. So that's your answer to part A. What percentage of the people are between 70 and 130 is going to be, it's 95%. Alright, and then let's look at this one. So if I go another standard deviation of that 15, it's going to be 145. Subtract 15, we get 55. So between 3 standard deviations above and below, you have 99.7% of the data is in there. So part B says, what percentage of people have an IQ score less than 55 or greater than 145? Okay, so if we look at the graph here, if 99.7 of the data is in between 55 and 145, it's asking you what percentage is less than 55 and more than 145. Then you have to do 100% minus 99.7%, and you get 0.3% is left just over here for those numbers below 55 and above 145. Okay, so that's the answer for part B. Alright, final question. What percentage of people have an IQ score greater than 115? Alright, so let's look. 115 is right here. So we're looking to see what percentage of people are in this region right here. Okay, so we know that it's 66 in the middle between 85 and 115. So I'm going to find what's on both sides. Okay, so on both sides of that middle region is 100% minus 66%, which is 34%. Because I'm only interested in bigger than 115 in only this upper section, we're going to divide 34 by 2 and we get 17%. Alright, so that's how that problem is done. I hope this clarifies your questions.